Hello everyone, welcome to this video on average rate of change. It's your first time being here, welcome. If you're returning, welcome back. Alright, let's get right into this. So, I always think of average rate of change as just the slope of a function between 2 points. Okay? So say we had a function that looked like this. Okay? Say we had a function that looked like this when we graphed it. Let's say I want the average rate of change from -6, say that point, which is -6, 6, and then we'll just say 0. Say 0. Okay. We want the average rate of change. The average rate of change between these 2 points, I'm going to connect it using this straight line right here. Average rate of change is just the slope of this. Okay, that's all average rate of change is. But let's get into the actual definition here. So the actual definition is change of y over change of x equals f of x2 minus f of x1 over x2 minus x1. Okay? So you're going to have some type of interval. Let's just say that's one number. We should just say, let's redo that. Let's say just we have some x value and we have another x value. In this case, our x values on this graph would be -6 and 0. We have two x values, okay? And you're always going to have the lesser x value on the left and the greater x value on the right. So this is always going to be x1, this is always going to be x2. Okay, and that's over your interval. So all you gotta do is just plug these numbers in and evaluate. So let's do that and hop into an example. Alright, let's hop into our first example here. We are going to be looking at the function f of x equals x cubed plus 1. And our first part, we'll be looking at the average rate of change from 2 to 3. And we'll go from -1 to 1 for part B. Remember, I'm just going to write the formula for average rate of change again. F of x2 minus f of x1 over x2 minus x1. And let's just graph this real quick. X cubed plus 1. Okay. So on part A, our interval from 2 to 3, we're not going to be able to show that up on the graph there, but let's just get started here. So I'm just going to write, I would just write AROC, just my abbreviation, my acronym for average rate of change. And remember, this is x1, this is x2. So let's just start plugging in values here. So we're going to have 3 cubed plus 1 minus 2 cubed plus 1 over 3 minus 2. Okay, and now I'm just plugging x2 into our f of x for this part, and I'm plugging x1 into our f of x for that part. Okay, so hopefully that makes sense. If we work this out, we're going to have, let's see, 27 plus 1 is 28, minus 2 cubed plus 1, so we're going to have minus 9, and just over 1. So this is going to equal 19. Okay, what about part B? This is from -1 to 1. So it's going to look something like that on our graph. And then we're just going to want to find the slope of that. Okay, so same thing as last time. This is x1, this is x2. Okay, we're going to have 1 cubed plus 1 minus negative 1 cubed plus 1 over 1 minus, 1 minus negative 1. And that comes out to, let's see, we're going to have 1 cubed plus 1 is 2, minus negative 1 cubed is negative 1, plus 1 is 0. Okay, so that won't have anything on the right side there, so I'll just cancel out, equals 0. And we're going to have 1 minus negative 1, which is 2, and this just comes out to 1. Okay, so hopefully everything made sense. Let's move on to the next example. Alright, and for this next example here, we are going to have g of x equals 2 plus cosine of x. This is our first trig function we've looked at. So our first interval will be from 0 to pi. And our next interval is going to be from negative pi to pi. Remember, this is x1, this is x2, this is x1, this is x2. Okay, and I'm just going to graph this real quick. So it's up to, okay. Okay, not the perfect drawing that I wanted there, but let's just get started evaluating this interval here. So we have a rock, average rate of change. Let's just start plugging in here. We're going to have 2 plus cosine of pi minus 2 plus cosine 0. And that's all going to be over pi minus 0. Okay, so simplifying that, I have 2 plus cosine of pi. Cosine of pi is negative 1. Minus 2 plus cosine of 0 is just 1 over pi. Okay, so we're going to have 2 plus negative 1 is negative 1, or not negative 1, excuse me, just 1. 1 minus, over here, 2 plus 1, so we have 1 minus 3 over pi, and this is just going to equal negative 2 over pi. Okay, and that's just after plugging everything into our formula. And our second interval here for part B, let's write a rock again. And we don't have a whole lot of room over here, so I'm going to write a little smaller. Got 2 plus cosine pi minus 2 plus cosine of negative pi. And that's going to be over pi minus negative pi. Okay. Simplifying all this, we're going to have 2 plus negative 1, just like in our previous example, minus 2 plus cosine of negative pi is just negative 1. And pi minus negative pi is 2 pi. Okay, so we're going to have 2 plus negative 1 is 1. I don't know why I always write negative 1 there. 1, and then 2 plus negative 1 is 1. So we're going to have 1 minus 1 over 2 pi. And let's look at this on the graph here. So we have negative pi, which is about right here. And we have positive pi about right there. Connect the lines. You obviously see the slope here is just 0. Okay, there's no change in our slope there. Okay, what about from 0 to pi? Let's just erase this here. 0 to pi is going to be from this point to here. Okay, it's kind of hard to see there, but this slope is just negative 2 over pi. Okay, let's move on to the next example here. Okay, and for this final example here, we're going to have the function f of x equals 2x squared minus 5x plus 3. And we're just going to calculate that rate of change here. We're not going to look at the graphs. Our first interval is going to be from negative 2 to 3. And our second interval is going to be from 5 to 7. Okay, so I'm just going to write arog, average rate of change. And let's just start plugging in. This is x1, this is x2, this is x1, this is x2. And if you want to skip ahead and see if your answers are correct, feel free to do so. Okay, we're going to have 2 times 3 squared minus 5 times 3 plus 3 minus 2 times negative 2 squared minus 5 times negative 2 and plus 3. And this is all going to be over 3 minus negative 2. Okay, so evaluating that, we're going to have 2 times 3 squared, so that's going to be 18. Minus 5 times 3, it's 15, plus 3. 2 times negative 2 squared is going to be 8. Minus 5 times negative 2, that's just going to be 10. I'm just going to change the sign. Plus 3. And then we're going to have 3 minus negative 2, which is just 5. Calculating all this out, we're going to have 18 minus 15 plus 3. That is 6. 8 plus 10 plus 3 is 21. So 6 minus 21 over 5. So this is actually going to come out to a really nice answer here. It's all just going to come out to negative 15 over 5, which is just negative 3. So that's a nice answer, considering what we started with. Alright, so part B here, let's just write this out again. A rock is going to be 2 times 7 squared. And once again, I'm going to try to write this a little smaller so I can fit everything in here. Minus 5 times 7 plus 3 minus 2 times 5 squared minus 5 times 5 plus 3. And we're going to have just 7 minus 5 on the bottom. Okay, let's multiply all this out. So we're going to have 2 times 7 squared. So that's going to be 2 times 49. It's going to be 98 minus 35. plus 3. Okay, and we're going to have 2 times 5 squared. That's going to be 50 minus 25 plus 3. And over 2. Okay, so 98 minus 35 is going to be 63. Plus 3 is 66. Okay, over here we're going to have 50 minus 25 plus 3. Okay, so that's going to be 28. So we're going to have 66 minus 28 here. And that's all over 2. So 66 minus 28 is 38. 38 over 2 is 19. Video helped everybody out on finding average rate of change using a graph as well as just the formula. Remember, average rate of change is really just the slope between 2 points, and you're taking the change in your y value over that certain interval, that distance of that interval. So if this video helped you out, please consider subscribing if you haven't already, and like the video if you enjoyed it. Alright, everybody have a great day.